In sixth grade, students start to divide fractions by other fractions, building off of what they did in fifth grade, where they divided whole numbers by unit fractions and unit fractions by whole numbers. Now students are going to divide with fractions by fractions. They could see mixed numbers, fractions greater than 1, unit fractions, fractions that are not unit fractions. Really all fractions or anything in fractional form is fair game in sixth grade for division. And this first strategy that we're going to look at for dividing fractions in sixth grade is going to build directly off of the strategy that we talked about in fifth grade, where we are dividing whole numbers by unit fractions. So I would encourage you, before you watch this, to check that video out because this is going to connect directly to that. And so that strategy was called think quotatively, and so you'll see that I'm calling this strategy the same thing, think quotative. And calling it that because if you'll recall from the last video, there are two ways to interpret division, and without context, sometimes if we have context, it tells us how to interpret that division, but without context, we kind of have some choice whether we want to interpret it quotatively or partitively. And so we're going to interpret this quotatively, so it's called think quotative. I also have there and common denominators. I'm not going to reference that right away, so maybe look out for why that might come up. But we're going to jump right into this. And first, I also want to say that the sequencing of dividing by fractions and how we teach students to divide with fractions and by fractions is really, really important. So you'll notice here that also we're only going to be working with whole number quotients. So though we're dividing fractions by fractions, these two examples are going to have whole number quotients. And that's really important for building the understanding and developing that reasoning. So these first two examples are going to be whole number quotients, and then this strategy is actually going to be a three-part video where we look at mixed number quotients, and then we also look at quotients that are less than 1. And developing that understanding in that order and in that sequence with this strategy of think quotative, I think is really important. So let's jump right in. 3/4 divided by 1/8. So the think quotative strategy is rooted in how we interpret this expression. So when we see 3/4 divided by 1/8, what we're asking is how many 1/8s are in 3/4. So to think quotative means we're asking that question. How many 1/8s are in 3/4? And to show that, I'm going to use a bar model. And actually, I'm going to use a stacked bar model. So I'm going to draw two bar models, one representing 3/4, one representing 1/8. And that's how we're going to be able to interpret and figure out how many 1/8s are in 3/4. So I'll start by representing 3/4. So I'll break my bar into fourths. We have 3 of those, so there's our 3/4. Now I want to know inside of here how many 1/8s do we have. So I'm going to draw another bar, and this one I'm going to show 8s. Now I want to make sure that my bars are lined up well. I know that I can get 8s out of fourths, or I can start with fourths and then partition further into 8s. So I'm going to make sure that I line these up here, and now I'm going to break each of these in half to have my 8s. There's also a really great digital tool that does this and shows these stacked bar models on GeoGebra. You can type in your fractions, it will create this for you. They line up really well. I'll make sure to put that link in the description. So 3/4 divided by 1/8. I want to know how many 1/8s, how many of these are inside of the 3/4. And the way that I'm going to figure that out is sort of just overlaying them onto each other and just seeing how many I can get out of that. And so if this were in 8ths, I think this would be a little easier to answer. So I'm going to go ahead and break that into 8ths. So now I'm actually, instead of thinking 3/4, I'm thinking 6/8 divided by 1/8. It's an equivalent expression there. So I'm thinking 6/8 divided by 1/8. How many 1/8s are in the 6/8? And so I see I've got 1, 2, 3, 4, 5, 6. So 3/4 divided by 1/8 is 6, because there are 6 1/8 inside of 3/8. And just like with 5th grade, where students can start to have a hard time reasoning what the quotients when we're dividing by fractions mean, if we're just teaching rules and we're not building understanding, the same thing can happen here. We're starting with a number less than 1. We're dividing it by something, and somehow my answer is a whole number that's larger than both. And they may have developed a misconception that when you divide, numbers always get smaller. And in this case, that doesn't happen. So understanding it from this perspective can really help to build their reasoning and help them understand what the division of fractions and division with fractions really means. So again, think quotative. We ask, how many 1/8 are in 3/4? We can draw that model, we can count, and we can see that. All right, I'm going to do this with the next example. So I have 5/3 divided by 5/6. And again, I'm asking that question. How many 5/6? How many of these things are in 5/3? So I'll start with my stacked bar model. I'm going to show 5/3. 1, 2, 3. Well, I need another model here, so I'm going to go ahead and draw one more. Split this thing. 4 and 5. And actually, to make this work a little better left to right, I'm going to move this one over here. So there's my 5/3. Now, I want to know how many 5/6 are in here. So I'm going to show sixths. And again, like last time, it was a little easier to think 6/8 and 1/8 so that I could stack them together. I know that I can start with thirds and then break each of those to get sixths. So 1, 2, 3, 4, 5. And then I'm going to break my thirds into sixths as well so that I can clearly see and count how many sixths. So I have 1/6, or how many 5/6 are in here. So now I can see where the sixths are individually. So this time, instead of counting each individual unit, because I wanted to know how many 1/8 were in 6/8, I have a group of them. I want to know how many 5/6, how many groups of 5 are in there. So I know that 5/6 looks like this. Marker bled on me a little bit there. So I'm looking for pieces that are that size. All right, so I see 1 here. So here's 1 5/6, and then, well, this is kind of broken apart, so I've got to think a little creatively here. Let me stop that from bleeding any further. But if I look at my 5/6, I can kind of count. There's 1, 2, 3, 4, 5 pieces in them. So let's see and just count 5 more pieces. 1, 2, 3, 4, and 5. Oh, that was perfect. So there's my second 5/6. So I have 1, 2. So 5/3 divided by 5/6 is 2. There are 2 5/6 inside of 5/3. And as you can see, there's a lot of intentionality in choosing the expressions that I'm choosing to show this. And in teaching with students, there needs to be a lot of intentionality with that as well. That's part of starting with those whole quotients. It's easier to count those whole pieces and easier to see those whole pieces than it will be when we have mixed quotients or when we have quotients less than 1. Conceptually, this is a little bit more friendly to grasp. So being very particular in the sequencing, starting with those whole number quotients, and also choosing denominators that play well. Because as you see, having sort of common denominators, we thought about, instead of 5/3, we broke it into sixths. So we thought about 10/6 divided by 5/6. So that's why we say and common denominators. Having the common denominator makes it a little bit easier to visually see and reason. And I'm not going to address it now, but there's also something else happening with the common denominators. Maybe you see it, maybe you don't see that yet, but in part 2 and part 3, we'll talk a little bit more about how we can also use common denominators, maybe even without the bar model, to interpret the division of fractions quotatively and find those quotients. So we'll see you in part 2 and part 3 when we look at mixed quotients and when we look at quotients less than 1 as we're dividing fractions thinking quotatively.